Hi everybody, we're going to go over section 2, which is our last section of chapter 2. And then after this, we're going to review and take a quiz on sections 1 and 2. Today we're talking about law of cosines. So hopefully you've seen this maybe once before. We usually learn it right after law of sines, okay? And in this lesson, you are going to learn how to use the law of cosines. We're going to solve oblique triangles and you use Heron's formula to find the area of a triangle, okay? So here is what we do for what the law of sines is. So first, whoops, this is too big. Sorry. So if triangle ABC has sides little a, little b, little c, we say the law of sines says this: a squared equals b squared plus c squared minus 2 times the sides of b times c times the cosine of angle A. Notice that the outside side is opposite the angle that we're listed. What if they give you a different angle? Well, then we'd say b squared equals a squared plus c squared minus 2ac times the cosine of b again. Notice that the side on the outside matches the opposite angle listed. And then finally, you could use the third version, which is c squared equals a squared plus b squared minus 2a times b times the cosine of angle C. And I think you know what I'm going to say, that the outside side is listed, matches with the given opposite angle. Keep in mind, we're going to use the law of cosines when we can't use the law of sines. And remember, we can use the law of sines when we have a given angle opposite of a given side. When we use the law of cosines, we will not have that case here. And I'll show you what that looks like in just right now in a minute. It says use the triangle at the right, find angle A. So we're going to look for this angle right here. Notice how just looking at this triangle, I see, okay, yeah, I don't have literally any angles. So I couldn't possibly use law of sines. I have to use law of cosines to find that missing angle. Okay, I'm going to come back up here right here. So if I'm looking for angle A, I want you to think about this. If I'm looking for angle A, remember the first thing that's going to be listed is the side that's opposite it, which is 20 feet. So we're going to say A squared equals side B squared plus side C squared minus 2BC times the cosine of angle A, because that's what we're looking for. With the law of cosines, you always list whatever you're looking for. If it's a side, you list it first. If it's the angle, it's the angle that you've listed, okay? And make sure that these two outside parts will be opposites of each other. So the angle listed has to be opposite the side listed in the front here. All right, let's fill this in. So we know side A is 20. Whoops. And then this is side B and here's side C, so that becomes 18 squared plus 13 squared minus 2 times 18 times 13 times the cosine of A. So we have to be able to get A by itself now. So we're going to do some math and kind of move some stuff over, okay? So I know 20 squared is 400 equals 18 squared plus 13 squared. I'm just going to do that together in my calculator. 18 squared plus 13 squared. This becomes 493 minus 2 times 18 times 13. If you put that in your calculator, it becomes 468 times the cosine of A. So remember, we want to get this A by itself, which means we're going to have to move stuff away from it. So we're going to subtract the 493, and we're going to get negative 93. Don't worry that it's negative. And this stays a negative 468, the cosine of A. I'm going to zoom in here a little bit. To get this cosine A by itself, we're going to divide by negative 468. okay? So we're left with, and I'm running out of room here, so forgive me. This tells me that 93 over 468, because two negatives divided equals a positive, equals the cosine of A. Now remember, to get the cosine off of the A, we're going to multiply both sides by the inverse cosine. This is going to cancel. So I'm left with A equals the inverse cosine of 93 over 468. So go ahead and put that in your calculator. Do not forget to your parentheses around the whole thing. And when we plug it in inverse cosine of 93 over 468, close parentheses, we get 78.5, and that's in degrees because we're looking for that angle. Okay, there you go. So one of the other things that we want to remember is when we're given the lengths of three sides and none of the angles, and you have to find all three, which should you find first? Go ahead and find the largest one. So remember, the largest angle is going to be usually opposite the largest side. And this will tell us so it's going to determine if the triangle is acute or obtuse. And that will tell us, if we have to find more than one triangle. All right, so number 2, in the triangle at the right, find if angle A is 62 degrees, find the length of side A. So we're given an angle this time, but we're not given its opposite side. So again, we're looking for side A. So remember how I said whatever thing you're looking for, it has to be on one of the outsides of the law of sine. So if I'm looking for side A, we're going to list it first. And then we're going to say A squared equals B squared plus C squared minus 2BC times the cosine of A. Now remember, these have to match, and they do. So let's plug in what we have. So again, we're looking for side A. We've got side B is 26, side C is 19, and we go 2 times 26 times 19 times the cosine of angle A, which is 62 degrees. This is a lot easier this time because we can just literally put this into the calculator just like this, and we'll get this really nice, easy to use number. Or you could break it up and say 26 squared plus 19 squared gives me right here 1,037 minus 2 times 26 times 19 is 988 cosine 62, and then plug that all in your calculator. Just make sure that your cosine is in parentheses. So I'm going to get A squared equals 573.16 with a lot of decimals behind it. Leave it just like that in your calculator. And then to solve for A, we're going to take the square root of both sides. So just take the square root of this whole thing. So we end up with A equals the root of 576.16 ... lots of things behind it. And we get 23.94 approximately. And the units on that are feet. Okay? And then for this last page, I don't know why it didn't come up in your note-taking guide. So we're just going to go ahead and write it in right here, okay, instead of applications, okay? So Heron's formula is what you can use to find the area of a triangle if we're not given the information that we were given before when we used the area formula from our last section, okay? And it says this, that the area is equal to the square root of S times S minus A times S minus B times S minus C. And that's where S is called the semi-perimeter, but basically we take all of the sides of the triangle and we divide it by 2, okay? So this is when we're not given any angles, because before we had a formula for finding area if we had one of the angles. This is where We don't have the angles, we only have the sides. So let's just say, for example, I needed to find the area of this triangle, and it has sides 53, 72, and 43. To find the area of this, we're first going to find the semi-perimeter. So remember, S equals A, which is 43, plus B, which is 72, plus C, which is 53, and we're going to divide that all by 2, which is pretty simple. So plug that in the calculator. 43 plus 72 plus 53 is 168, divided by 2 is 84. So now I'm going to plug that into the formula for Heron's formula. I'm going to say A equals the root of S, which is 84, times S minus A, that's 84, minus A is 43, because that's A, times S, which is 84, minus B, which is 72, times S, which is 84, minus C, which is 53. So now we're just going to do some really basic math here. So 84 minus 43 is 41. 84 minus 72 is 12. And 84 minus 53 is 31. So we're just going to plug that whole thing into the calculator. So you're going to take the root of, and then you can type in the whole thing, 84 times 41 times 12 times 31, end parentheses, and we get approximately 1,031.89, and we would call this units squared, whatever units they gave us, because it is an area. All right, you guys, I'll see you back in class.